Good morning, students. Today we will discuss about furan. Okay, introduction of furan and methods of preparation of furan. First, we will discuss about the introduction. Okay, furan is also called furfuran. It is a 5-membered heterocyclic ring. Okay, and in this all atoms, that is 4 carbon atoms and 1 oxygen atom, all are sp2 hybridized. All sigma bonds are in plane. Third, sp2 hybrid orbital is filled. And let us see the structure of a furan. This is a 5-membered ring. In structure, and it is also written as CH, double bond, CH, double bond, CH. These are open structures. The bond which is present in between carbon and hydrogen is a sigma bond. That is a carbon hydrogen bond is a sigma bond. It is sp2 as a bond. And next, carbon-carbon bond is also a sigma bond. Carbon-oxygen bond is also sigma bond. That is, this is a sp2 bond, and carbon-oxygen also sp2 bond. Okay, let us see the sigma bond structure and also orbital structures of furan. We are having 3 types of sigma bonds. Okay, that is, one is in between carbon and hydrogen, that is sp2 as a sigma bond, and a carbon-carbon bond, that is sp2 sigma bond, and a carbon-oxygen bond, that is sp2 sigma bond. This is a sigma bonding structure. And next one, orbital structure. Filled sp2 hybridized orbital. Hybridized p orbital. First, we have to know about what are hybridized orbitals and what are hybridized orbitals. The carbon atomic number is 6 and its electronic configuration is 1s2, 2s2, 2p2. 1s, 2s, 2p. Okay, 1s orbital contains 2 electrons, 2s orbital contains 2 electrons, and p orbital contains 2 electrons. Okay, this is a ground state electronic configuration of a carbon atom. Okay, in excited state, one of the electron which is present in 2s orbital is close to 2p orbital. Okay, that is a 2s orbital contains only 1 electron, and then 2p orbital contains 3 electrons. 3 electrons. Out of these 3, okay, the 2 px, py, and 2s are undergo hybridization, that is a sp2 hybridization. sp2 hybridization, and these orbitals are called hybrid orbitals. And this is the p orbital which is not involved in hybridization. This is called unhybridized p orbital. That means carbon contains 3 sp2 hybridized orbitals and 1 unhybridized p orbital. Okay. Carbon contains 3 sp2 hybridized orbitals and 1 unhybridized p orbital. The atomic number of oxygen atom is 8 and its electronic configuration is 1s2, 2s2, 2p4. Okay, that means 1s orbital contains 2 electrons, 2s orbital contains 2 electrons, and the 2p orbital contains 4 electrons. 1, 2, 3, 4. Okay, this is a ground state electron configuration of oxygen atom. Okay. In excited state, 1s contains 2 electrons, 2s is having only 1 electron, and 2p is having 5 electrons. Okay, the reason one of the electron is magnetic to this. Totally, it contains 3 p orbitals and 1 s orbital. Out of these, 1s and 2p orbitals, these orbitals are called sp2 hybrid orbitals, and this one is called unhybridized p orbital. That means the oxygen atom is also having 3 sp2 hybridized orbitals and 1 unhybridized p orbital. Okay, this unhybridized p orbital is having 2 electrons. Okay, 3 sp2 hybridized orbitals involve in 3 sigma bonds. They form 3 sigma bonds with carbon-carbon and carbon hydrogen and carbon carbon. Okay, this is an unhybridized p orbital which contains 1 electron. 1 electron in each carbon atom. Okay, and next the oxygen atom. Okay, it is having 3 sp2 hybridized orbitals. Out of these 3 sp2 hybridized orbitals, one is filled sp2 hybridized orbital. This one is unhybridized p orbital. And remaining 2 sp2 hybridized orbitals forms a sigma bond with the adjacent carbon atoms. Okay, one is this bond and also this one. The unhybridized p orbital containing lone pair of electrons. Okay, these lone pair of electrons involved in delocalization. This is about the structure of a furan. And next, preparation methods of a furan. First, from nucleic acid, COOH, CHOH, 18-4, and COOH. This is a nucleic acid. Okay, this is also written as CHOH, 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 COOH, and COOH. This nucleic acid on dry distillation. Uses 1 molecule of CO2 and 3 molecules of water, and it is converted into CH, double bond, CH, O, C, COH, fluoric acid. Okay, the form of this fluoric acid react with soda lime. It is a sodium hydroxide and also calcium oxide is called soda lime. On heating, it gives a furan. CO2 is eliminated. First, the nucleic acid on dry distillation. Dry distillation is also called destructive distillation. It is one type of pyrolysis. Pyrolysis in absence of air. Second preparation, that is from furfural. Let us see the equation. Furfural means pharma group is present at the second position of the furan. If you are removing this pharma group, we are getting furan. Okay, for this furfural undergo oxidation. Oxidation means addition of oxygen or the removal of hydrogen atom. Okay, in this we are adding one oxygen atom to this pharma group. Okay. Okay, and this formyl group is converted into acid group, that is a COOH group. Okay, this is called a fluoric acid. Okay, the form of this fluoric acid react with this soda lime, that is sodium hydroxide with calcium oxide. Soda lime, it eliminates CO and it is converted into fluorine. Okay, this is the second preparation method. Third preparation, that is a polymer synthesis. Very, very important ingredient. Polymer synthesis means in this the 1,4 dialdehydes react with phosphorus pentoxide. It is converted into fluorine. 1,4 dialdehyde react with phosphorus pentoxide in presence of heat. It is converted into fluorine. Okay, in this we are taking the succinic dialdehyde as an example. Okay, CH2, CH2, CH double bond O, CH double bond. This is a succinic dialdehyde. Okay, if you are giving number 1, 2, 3, 4, these are 1,4 dialdehyde. This is succinic dialdehyde on tautomerization. Tautomerization. Tautomerism means a simple transfer of proton in intramolecular fashion. Okay, that means the proton transfer takes place within the molecule. So it is called a tautomerization. Okay, this is succinic dialdehyde under the tautomerization. It is converted into dienediol. Okay, di means two double bonds, and diol, two alcoholic groups. So it is called dienediol. It is an enol form. Okay, the form of this dienediol, which is an unstable species, which can react with the phosphorus pentoxide, it loses a molecule of water, okay, from here, and it is converted into fluorine. How will you get this dienediol from this succinic dialdehyde? Okay, see here, this is succinic dialdehyde. You can also write like this. Okay, the bond which is present in between carbon and hydrogen is a breakdown. Okay, carbon gets a negative charge and hydrogen gets a positive charge, because carbon is a more electronegative than hydrogen atom. And like this, here also the bond is breakdown, hydrogen gets a positive charge and carbon gets a negative charge. And here the oxygen atom contains a pair of electrons. Okay, this pair of electrons abstract this proton. Okay, proton, hydrogen, and hydrogen. Okay, and then here oxygen is having three bonds, so it gets a positive charge. For getting stability, it removes its positive charge. The bond is a breakdown between oxygen and the carbon atom. Okay, in this, the oxygen is a more electronegative than carbon atom. So oxygen gets a negative charge and carbon gets a positive charge. Here also oxygen gets a negative charge and carbon gets a positive charge. Okay. See here, the positive and the negative charge gets neutralized. And here, this carbon is having negative charge and this carbon is having positive charge. Okay, there is a bond, a new bond is formed between these two carbon atoms. And here also, a new bond is formed. We are getting diene-diol structure. Good morning, students. Today we will discuss about the thiophene. Okay, this is the structure of a thiophene. Okay, in which we are dealing with the introduction, structure, and preparation methods of a thiophene. Okay, first we have to discuss about the introduction. Okay, this thiophene is also called thiol, and it is a 5-membered heterocyclic compound. In this thiol, it contains total 5 atoms, in which 4 are carbon atoms and 1 is a sulfur atom. And these 5 atoms are sp2 hybridized. Sulfur contains two lone pair of electrons. Okay, see here, this is one lone pair and this one is another lone pair. Okay, out of these two lone pairs, one lone pair of electron is present in sp2 hybrid orbital and another lone pair is present in unhybrid p orbital of a sulfur atom. This is about introduction. And next, let us see the structure of this thiophene. This is the structure of thiophene. Okay, this thiophene can also written as CH, CH, double bond, CH, CH, S. Okay. In this thiophene structure, we are observing three types of sigma bonds. One is carbon-hydrogen sigma bond, and one is a carbon-carbon sigma bond, and another one is a carbon-sulfur sigma bond. And this carbon-hydrogen sigma bond is formed by the overlapping of sp2 hybrid orbital of carbon atom with s orbital of hydrogen atom. And this carbon-carbon sigma bond is formed by the overlapping of sp2 hybrid orbital of carbon atom and also sp2 hybrid orbital of another carbon atom. And this carbon-sulfur sigma bond is formed by the overlapping of sp2 hybrid orbital of carbon atom with sp2 hybrid orbital of sulfur atoms. Okay, this is a sigma bonding in thiophene. Okay. Now we will discuss about the orbital structure of a thiophene. Okay, in this we already know carbon atom is having 3 sp2 hybridized orbitals, in which 2 sp2 hybridized orbitals form a sigma bond with adjacent carbon atoms. For example, this carbon atom in which it forms this one and this one, 2 sigma bonds. Okay, and another one sp2 hybrid orbital of carbon atom form a sigma bond with hydrogens. And the carbon atom contains one unhybridized p orbital. Okay, this unhybridized p orbital contains single electron. Okay, this is the unhybridized p orbital of carbon atom, which contains a single electron. The atomic number of sulfur is 16, and its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4. Okay, that means if the outer shell orbitals, that is 3s and 3p orbitals, contains total 6 electrons. Let us see the ground state electronic configuration of this sulfur atom. The 3s orbital contains 2 electrons and the 3p orbital contains 4 electrons. Okay, the filling of electrons takes place according to Hund's rule. Okay, p orbital contains 4 electrons. Okay, in which px contains 2 electrons, py contains only 1 electron, and pz contains only 1 electron. Okay, and in excited state, one of the electron which is present in 3s orbital, that is this electron, is goes to 3p orbital. That means 3s orbital contains only 1 electron and 3p contains totally 5 electrons. Out of these orbitals, the 3s, py, pz orbitals are involved in sp2 hybridization, and this px orbital is called unhybridized p orbital. This unhybridized p orbital is having lone pair of electron. Lone pair of electrons. Okay, that means totally the sulfur atom contains 3 sp2 hybridized orbitals and 1 unhybridized p orbital. Okay, out of these 3 sp2 hybridized orbitals, 2 sp2 hybridized orbitals involved in the formation of sigma bond with the adjacent carbon atoms. You see here in this structure, the sulfur atom forms 2 sigma bonds. Okay, this one is 1 sigma bond, this is another one with adjacent carbon atoms. Okay, that means 2 sp2 hybrid orbitals of sulfur atom involves in the formation of sigma bond with adjacent carbon atoms. Okay, and another one sp2 hybrid orbital of sulfur atom is having 2 electrons. That means is filled sp2 hybridized orbital. Okay, and it contains 1 unhybridized p orbital. This is a unhybridized p orbital. It contains a pair of electrons. Okay, this is a unhybridized p orbital of sulfur atom. Contains a pair of electrons. Okay, the electrons which is present in unhybridized p orbital of sulfur involved in delocalization. Okay. Involved in delocalization. This is the orbital structure of thiophene. And next, preparation methods of thiophene. First preparation method is from sodium succinate. This is the structure of sodium succinate. This is sodium succinate on heating with phosphorus trisulfide, thiophene is formed. Second preparation, that is from acetylene. 2 molecules of acetylene and 1 molecule of hydrogen sulfide passed through red hot tube in presence of aluminum trioxide at 300 degrees centigrade temperature. Thiophene is formed. In third preparation, that is from furan. Furan react with hydrogen sulfide thiophene is formed by the elimination of water molecule. In this, how we are getting this thiophene from this furan? Okay, let us see here. We are writing hydrogen sulfide here. Okay. The bond which is present in between oxygen and carbon is a breakdown. Okay, carbon gets a positive charge and oxygen gets a negative charge because here oxygen atom is more electronegative than carbon atom. And here also this bond is a breakdown and carbon gets a positive charge and oxygen gets a negative charge. Okay, and the bond which is present in between sulfur and hydrogen is breakdown. Hydrogen gets a positive charge and the sulfur gets a negative charge because sulfur is more electronegative than hydrogen atom. And this bond is also breakdown. Hydrogen gets a positive charge and the sulfur gets a negative charge. Okay, the positively charged hydrogen atoms bonded with this negatively charged oxygen atom and it is eliminated as a water molecule. And the carbon atoms, positively charged carbon atoms are bonded with the negatively charged sulfur atom and we get a thiophene. Fourth preparation, that is from furoic acid. This is the structure of furoic acid. React with barium sulfide. Thiophene is formed by the elimination of barium carbonate. This is the fourth preparation method